Welcome again here at our Speakers Corner, and we are ready for our next presentation on stage. The style, shape, and mass of cast products create challenges, combined with high surface requirements for visible and mounting surfaces. To meet these requirements, casters need to adopt their process parameters, which increases the stress on the die. Steel makers support die makers and die casters by improving existing steel grades or by developing new grades with improved properties. This will be addressed in Giga casting requirements and solutions for dies from a dual IDEOS producer's point of view. And therefore, I'm happy to welcome Ingolf Schroff, his business development at RR Special Steel Ring Mill Spa. Welcome on stage.
Thank you. Thank you, Mrs. Bindel, for your kind introduction. Ladies and gentlemen, good morning, and thanks for your interest in my presentation. On behalf of RR Special Steel, I would like to welcome you to my presentation on Giga casting requirements and solutions from a tool steel producer's point of view. Let me give you a short overview of what I want to talk about here during the next 20 minutes so that you are a little bit informed of what is going on here. I will start with an introduction of the company, RR Special Steel, and then we'll try to give some definition from my point of view. I will talk about the challenges which arise from the Giga casting process and which influence the die casting dies. And that is with respect to the size, the design, and the mass of the dies, and finally also the chemical composition of the casting alloys. From these challenges, I will derive the properties which a suitable hot work tool steel shall provide. I will then introduce the hot work tool steels which RR Special Steel produces for the die casting applications, and I will show how these steels can be differentiated with regard to mechanical properties as well as thermal shock resistance. This description is then rounded off by some recommendations for the selection of suitable steels and also for the hardness definition of hot work tool dies for large giga casting applications. I will, at the end, show some examples of dies that had been made successfully with steel from RR Special Steel. And at the end of my presentation, after my conclusion, I will be available for your questions. Ringmill SPA, the company was founded in 1978 by the grandfather of the current managing directors of Ringmill and Rubiera Special Steel. These two companies belong to the same group, and they employ roughly 450 employees over 5 production sites in northern Italy. The brand RR Special Steel was created in 2020 in order to commercialize the tool steel under one name, which unifies both companies. The red R represents the red R represents Ringmill, located in Dubino, located at the wonderful lake Como in Italy, and the blue R represents Rubiera, located in Casal Grande. The production facilities include an electric arc furnace, electroslag remelting and vacuum remelting facilities, a 6,300-ton forging press and 2 smaller forging presses, heat treatment facilities, and of course also a quality department. All companies are certified according to the standards which you see on the bottom line. They all manage their own sustainability and carbon footprint, and also publish a sustainability report every year. And so these companies are ready for the so-called green steel. Let me start with a kind of definition of the term Giga casting, as I will handle it in this presentation. In 2020, Tesla and Press together came up with a new magnitude of die casting when they introduced the huge die-cast rear underbody structures of a Tesla passenger car. We had already seen other large die-cast structural components like door frames, tailgates, and shock towers, but this time the dimensions were far beyond anything that could have been imagined before. As my presentation does not only focus on the die-cast underbody structures alone, but also on other large die-cast products like dies and shock towers, I would like to use the term mega casting, which explicitly includes the die-cast structural components like shock towers, instrument panels, as well as battery cases or underbody structures. This wording also allows me to give a more neutral description of the technology. In all these cases, we see a combination of functional as well as visible surfaces in the casting, and this combination leads to, on the one hand, to a high degree of functional integration, but it is also, on the other hand, the reason for the high requirements on the dies and on the properties of the hot work tool steels for the dies. We all, die casters, die makers, and of course the producers of hot work tool steels, see ourselves challenged by the size, design, and the mass of the casting. Here we see a die-cast tailgate of a modern passenger car, and it is a good example for the large size. We have very long flowways in the die to sufficiently fill the dies, and we need to have high flow rates and casting temperatures in order to avoid the undesired and critical pre-solidification during the filling process. All this leads to high mechanical and thermal impacts on the die surfaces with each shot. The combination of visible and functional surfaces within one grade casting requires a hot work tool steel with high temperature strength for the delay of crack initiation. We need to have a high tempering resistance to avoid the critical softening during the process. We need to have a high toughness potential to delay crack propagation. And finally, thermal shock resistance for the high qualities of the die-cast surfaces. These two photographs of a die-cast longitudinal member of a passenger car illustrate the challenges by design very well. On the one hand, we see very many sharp bends in the geometry, often in all three dimensions. And sharp bends in the geometry means different wall thickness in the die. In such positions, we typically find high stress concentrations, both during hardening and tempering, but also later on in the die casting process. We see many stiffening fins here in the cast product, which stabilize the product. The corresponding grooves in the die are internal notches and locations of stress concentrations. And as these grooves are often made by electric discharge machining, these spots are very sensitive to early cracking. That means, again, the die with numerous deep grooves require hot work tool steel with the very high toughness potential to delay the crack propagation in these sections. The mass of these large castings also are a great challenge for the die. Here we see a die-cast underbody structure of a passenger car with a finished weight of approximately 130 kilogram, and that means a shot weight of approximately 160 kilogram. And if you imagine that these 160 kgs of liquid aluminum with a temperature of more than 720 degrees have to be shot into the die within a fragment of a second, you can certainly imagine how high the flow rates are and how extreme the mechanical and thermal stresses will be in the die. And to withstand these high impacts, the die steel must have a high tempering resistance again. It must have a good high temperature strength and excellent impact toughness. Challenges by casting alloys. What do I mean with that? A number of different aluminum alloys have been developed, especially for these large die castings. Their casting temperature ranges from 680 to 730 degrees, and this temperature range is significantly higher than that of the classical aluminum alloys, like aluminum 226, which typically has a casting temperature of maximum 650 degrees centigrade. Consequently, the thermal impact on the dies is high, and we face a high risk of undesired softening of the dies and early cracking initiation. So, especially for these alloys, the die steels need to have a very high tempering resistance and high temperature strength again. Among these new aluminum alloys, a few are characterized by a low iron concentration. And these develop a chemically aggressive behavior against the die steel because liquid aluminum has the unpleasant characteristic that it dissolves steel. And that means the higher the casting temperature and the lower the iron concentration in the aluminum alloy is, the more aggressive is the material, the cast alloy against the die steel. This is something we can hardly encounter with the steel, and that is why we need to consider a coating like PVD coating on the die surface in this case. On the previous slides, I wanted to throw a light on the challenges by size, dimension, and mass of the castings, but also by the constitution of the used alloys. These challenges are responsible for the fact that mega casting or giga casting leads to a stress situation in the die far beyond those which we had known previously. Stresses in the die can easily exceed the limits of applicability of the traditionally used hot work tool steels like 1.2343 or 1.2344, H11 or H13. And as I mentioned before, suitable hot work tool steels for dies withstanding these extreme loads need to provide an improved tempering resistance, a very high temperature strength, excellent impact toughness or ductility in order to compensate the abrupt mechanical and thermal stresses, and finally, a very high thermal shock resistance for the high surface quality of visible and of mounting surfaces. How can RR special steel support the die casting industry, especially in mega casting? This table introduces the 4 grades that we produce for the die casting industry. The grade is Altair, Astro, Antares, and finally Sirio. These grades are produced using up-to-date electroslag remelting technology. And on demand, if a further improvement of the cleanliness is required, they can also be delivered from vacuum arc remelting technology. All 4 grades fulfill the technical and quality requirements of the NADCA specification 207 from 2024, and Sirio is expected to be taken up into the specification very soon. Astro and Antares are equivalents to the most frequently used grades 1.2343 and 2344, and Sirio is a own development designed with excellent tempering resistance, toughness, and high temperature strength for a good thermal shock resistance. How can we differentiate between these grades? The first differentiation is the tempering resistance of the steel. And these tempering curves are, on the one hand, a good tool for the heat treater because it helps the die heat treater to set the correct working hardness of the dies. But it is also a good tool to differentiate between the grades with regard to the undesired softening or the resistance against softening. The characteristic, how steep these curves decline here after the secondary hardness maximum, describe very well the resistance against softening. And you see the grades Altair, Astro, and Antares are very similar in tempering resistance, but the red curve for Sirio exceeds the other grade in tempering resistance. The curve is shifted towards higher tempering temperatures, and also we see that the decline is less steep after the secondary hardness maximum. High temperature strength is an important property to guarantee the stability of the die cavity. And here we use the so-called yield strength RP 0.2, which we determine in the tensile test, in order to compare the strength and the grades at increasing test temperatures. What we see is that up to a test temperature of approximately 350 degrees, there is not really a significant difference in between these grades. But at higher test temperature, above 350 degrees, we see a clear advantage of Sirio. And if you have in mind what I just mentioned about the casting temperatures of some newly developed alloys, we must keep in mind that the surface of the die reaches, at least for a short moment, a surface temperature of 500 degrees or even higher with each shot. And that is, of course, a very high thermal load which the steel has to withstand with every shot. And this improved high temperature strength certainly explains the beneficial effect of Sirio. The extreme mechanical loads during casting require highest impact toughness. This comparison underlines the drastically improved toughness of Sirio, which you see on the right side, and you also see on the left side a very high column that is for Altair. This high impact toughness is due to the fact that this material was made by vacuum arc remelting. So that gives it also an outstanding toughness. Thermal shock resistance of the steel is not a single material property. It can be related to high temperature strength and toughness simultaneously, so the cooperation of these two properties is responsible for a good thermal shock resistance, and that is, of course, a very important property if we come to visible surfaces in the die. And we see very well that Sirio here offers the best resistance against thermal shocks. After so much of theory, the question is what to do with megacasting dies. We have to consider two options. The first option is that the die designer requests the die to be built from only one block, not a segmented but a monoblock die insert. And this means that we have to take the large dimensions into account, and so there is only more or less one choice of material because of the high stresses in these dies and of the high toughness potential, and that is Sirio. One also has to keep in mind that for these large monoblock inserts, we need to widen up the range of hardness. In this case, for example, to approximately 42 to 45 Rockville-C. Of course, that depends a little bit on the design of the cavity and should be discussed from case to case. If, for any financial reason, Sirio grade is not the selected material, then one should take Astro, the equivalent to the grade 1.2343. But then you should keep in mind that you should lower the hardness a little more to gain a little more toughness from that material. In this case, I mentioned 41 to 44 Rockville-C, but again, this also depends on the design of the die. In the second option, I want to discuss the chance to build a segmented die, which will bring us several advantages. The raw blocks for the segments can be cut from smaller forged bars, and within the individual segments, we can expect a simple stress situation. Steel grades like Altair and Astro can now be taken into account, and the hardness range can be a little narrowed again. And within these segments, we get then a better thermal shock resistance. And one great advantage of segmented large dies is that the heat treatment of these partial die inserts is much easier as it is for one large monoblock. At the end, I want to show a few examples of dies that had been made successfully of the grades from RR Special Steel. Here we see, for example, a large die for an automotive door frame made of the grade Astro. The weight of the die was 2.5 tons, and the hardness here ranged from 44 to 46 Rockville-C. All the examples that I show are still successfully under operation, and it is too early to give a statement on the lifetime, but they are still working without complaints. The second die that I want to show was made of Sirio. We see a very deep excavation in the die insert. It is a die for an automotive structural part. Again, you see the dimensions. The weight was 3,600 kilograms, and the hardness range was 42 to 44 Rockville-C. And the third one is also an example for Sirio, a structural part of 3,000 kilograms with a hardness range of 44 to 46 Rockville-C. You see the hardness of the Sirio dies can be slightly higher than that of the Astro dies because the Sirio material has a better toughness potential. And now I would like to conclude my remarks. You all know Giga casting and mega casting are the current keywords, magic keywords in the die casting industry. And wherever you look around here on the exhibition, you find examples for very large dies and for castings. This trend in die casting creates extreme challenges for the die designers, the die makers, but also on the steel suppliers who have to provide the matching steel grades. And the challenges are the die size, the size of the casting, the design of the casting, the mass of the casting, and finally also the casting alloys, which were especially developed. A suitable hot work tool steel requires properties which are adapted to the higher stresses during casting process, which is mainly, again, high temperature tempering resistance, higher high temperature strength, very high impact toughness, and as a result of that, an improved thermal shock resistance. For these particular requirements, RR Special Steel provides the hot work tool Serio with properties which are well adapted to the requirements of the mega casting and giga casting cases. I could show a few examples that obviously work successfully in the industry. And now I'm at the end of my presentation. I would like to thank you for your kind attention. And I am open now for your questions, either here or later on in our booth, numbers 365 in Hall 7. Thank you very much.